Hi, I'm Frank Buchholz, a Director of Technical Marketing on the Microsoft Surface team. Today we'll be diving deep into Surface's approach to implementing new features to support modern work. Specifically, we'll dive into artificial intelligence, neural processing units, and machine learning functionality in our latest products designed to enable better hybrid work scenarios. We'll discover how Surface is driving innovation that is unlocking the capabilities across the entire Windows ecosystem of devices for better employee productivity and collaboration, whether they're in the office or remote. Artificial intelligence seems to be the big thing these days. Everything is AI this or AI that. But once you look beyond the hype, the world of machine learning is a fascinating perspective of how computer scientists harness the statistical process to make sense of information in a noisy and unpredictable world. Let's jump straight into this and use a real-world example of how you can recognize a cat from a dog. So at an early age, we're taught what a cat looks like. Our brains essentially develop a neural pattern of a basic cat. Over time, the more cats we see, the more precisely we're able to tune the neural pattern, allowing us to recognize different types of cats and easily identify them. If we were to mimic this artificially through a computer, we could do this through the use of software and the use of a CPU, which is a generic processor. The problem with a CPU, though, is that essentially it executes one line at a time and loads one piece of information at a time. We would quickly learn that we need to move a pixel of data that stood for a tiny part of the cat between memory and the CPU. The problem is this consumes an overwhelming amount of computer resources and the time to process it. This is an inefficient way to find a cat. We know that a GPU, or a graphical processor unit, can process very specific calculations very fast, such as the points on a triangle. A GPU, though, is a lot like a CPU. You still need to load information from memory into the processor, but the advantage of a GPU is that you can actually process all these points simultaneously or in parallel. To find a cat, a GPU can process in parallel an entire vector of pixels on the cat simultaneously. However, the circuitry on a GPU is built for precision of fractions, where in our case, we just need to build a neural pattern that symbolizes a cat in whole numbers. We don't need all of that extra load that fractions bring. Modern computer chips consist of billions of transistors packed into the silicon of a processor. In this case, we have system-on-chip design, like on this phone, like this Duo 2 or this new Pro 9 with 5G. And we can essentially take that system-on-chip design and distribute a specific number of transistors, even a few hundred million, because there's billions of transistors on the system-on-chip, and we can essentially create a new thing called a neural network, or in our case, it's a matrix of transistors that are used to calculate the representation of a cat all at once. We call this dedicated space of transistors for neural networks a neural processing unit. To simplify it all, think of a CPU as having the ability to print a single character at a time, where a GPU can print an entire sentence because of its parallel capabilities. But an NPU can print an entire page at a time, and that just brings the value of being able to process things like audio and video. Now that we have a neural network which is built out of a vast array of transistors, let's move over to a hybrid work problem. A great example is the background blur feature on a Teams call, which is useful if I'm sitting in a coffee shop where I'd like to hide what's occurring behind me. Today, background blur in Teams is processed using software on a CPU or even cloud-based processing. Much like finding a cat, software can find a human face and then figure out what it needs to blur, which is essentially everything but the human face. However, the processing is taxing, as we've talked about. It consumes a lot of power on the device itself, which is essentially heat, and the computer needs to work hard in order to remove that heat and keep up. With a set of transistors dedicated to neural representation of the human face, the speed to find the process not only becomes extremely fast, but also consumes far less power. The NPU is showing itself to be a highly valued processing unit for specific workloads that require neural networks. But the real value is that we're able to do this in a slim, lightweight form factor that mobile professionals demand. Let's bring an expert in from our engineering staff to dive deeper into this topic. Hey, so let's dive a little deeper into the technology of NPUs. I'm not the expert here, so I've brought in Fred Balsiger, who joins me from the Windows engineering team, where he heads up silicon-based AI strategies on Microsoft's Windows, Silicon, and System Integration team. It's a pleasure to have you.
Thanks, Frank. Happy.
Yeah, this is awesome. So, hey, first, let's level set on some terminology and how Microsoft, and in particular Surface and Windows, implement these technologies. Now, for decades, there's been a lot of groundbreaking research when it comes to AI or artificial intelligence, but there's also been a lot of hype. So, Fred, how would you define the use of AI and how we're implementing it to solve real-world problems?
Right. So, given the hybrid environment many of us now work within, there are groups at Microsoft looking to AI solutions to better create a more authentic collaborative experience. And so what we can do if we invest in AI in the audio and video channels is create a more authentic person on the camera. What that does in turn is lets you worry less about barking dogs in the background or not looking your best on the camera. It lets you worry about, let me go do my job at hand, the collaboration, let me explain my ideas. And so I think that there's some real righteous work we're doing here with responsible AI to go reduce some of those cognitive loads on your mind as you're doing your day-to-day work.
What I really love about that is we're using this to actually solve real-world problems that maybe we didn't even have pre-COVID,
right?
But we're actually seeing much more scenarios where people are working in so many different locations, and we want to be able to use this device like this amazing Surface Pro 9 5G in order to light up those experiences. So, hey, where does all this AI exist? I hear a lot about AI advancements in a new tooling called Windows Studio Effects being brought forward within the latest version of Windows, but I'm curious how operating systems implement AI when not all hardware has the capability to support that AI.
No, that's exactly correct. Like there is a marriage between the Windows OS and the specific hardware that's running on top of it. This is exactly how Windows Studio Effects work today. So, for this coming holiday, there are a select few Windows machines that will leverage the Qualcomm HCX Gen 3 silicon to go expose these Windows Studio Effects. We are continuing to go engage with other OEMs and hardware vendors to go make sure that as they continue to build out their Windows ecosystem of devices, that they also go expose these effects.
Oh, that's super cool.
Yeah.
So Fred, what I find interesting as we talk about these advancements into Windows is that some of these capabilities have actually been available inside of a phone for the last few years. In fact, here I have my Surface Duo 2 with its Qualcomm 888 5G processor inside of it. But one of the things that I could do is I could actually take a picture of this amazing Pro 9 5G and it would actually find it, but the neural processing may take me to a website where I can learn more about it. So Fred, how are these advancements in phone-based processors, what is commonly known as System on Chip or SoC, helping to advance PCs such as the Surface Pro 9 5G?
Good question, and you somewhat touched on that with the 5G reference.
Right.
Phone-based processors, or SoCs as you called out, are designed from their inception to be small, thermal, and battery friendly, and most often connected to a modem, 5G for example, right? So as the demand for mobile PCs continues to grow, it makes a good deal of sense to leverage these SoC processors in PCs, especially as they become more and more powerful at an increasing rate.
I think that's the key, right? I mean, now they've become so powerful that they can drive a PC instead of just driving what we would think of as a phone. And we're able to bring those technologies into a hybrid work scenario for commercial workers, maybe what consumer people were using in the past. So hey, it sounds like Surface team has done a lot of great work in essentially the development of some of these advancements that have gone into Windows Studio Effects. Is this something that really helps the rest of the Windows ecosystem, and especially those that are using the Qualcomm HCX Gen 3 processor?
Yeah, so there are other hardware vendors we're obviously working closely with, as well, that have future plans to embrace the Windows Studio Effects on their, up-and-coming neural processing units.
Right.
So you'll see future tech across the industry leverage these dedicated NPUs, and you'll see a broader and broader ecosystem of Windows Studio Effects across all of our Windows machines.
Oh, that's cool. So hey, Fred, I've always been fascinated with the blend of computer engineering and computer science, essentially that hardware and software coming together. And it feels like this technology is being represented well within an NPU because the melding of those lines are getting closer and closer. So that brings us to our final definition that we're looking for, and that is machine learning. Now, I've watched futuristic movies like Ex Machina and then TV shows like Westworld where honestly machine learning and the representations scare me a little bit. Those robots don't do good things to humans, it turns out. But let's talk about machine learning and how it's used within Windows and on Surface devices to enhance hybrid work environments. So one of the things I hear about machine learning are the two distinct phases of training and inference. And Fred, maybe you could tell us a little bit more about these AI features delivered in Windows Studio Effects. And based on the work done by the Surface team, can you tell us more about how the Windows team takes part in both the training and inference phases of AI capabilities for the NPUs that are being used for Windows Studio effects?
Absolutely. Like, at the highest level, the idea is to train your models with an existing data set, right? And so the larger the data set, the better you're off, the more accurate your models are going to be and better trained. This is where also, again, responsible AI comes into place, where if you're training models that deal with things about humans, you want to make sure you grab every type of human you can so that your models work better. Training a model, this can be done in many locations. From a hardware perspective, CPU, GPU, it can also be done in the cloud and Azure, given infinite size restraints and whatnot. But then when it comes time to execute your model, or as you were saying, inference, it's the correct term, this is when real-world data is now your input. You're no longer running the model on an existing data set. It's all about the real-world data. And so that is when you want to leverage the silicon, such as your NPU, to get the most performant execution.
No, that's all super cool. And you know what? We've done a lot of talking, and hopefully people have been following what we've been saying. But hey, instead of talking, let's actually take a look at some of these capabilities. We have a short video made by some super talented engineers on our Surface engineering team, as well as Windows side, of Oyen and Anton, and we want to have them showcase the capabilities of what is in Windows Studio effects. So let's roll the videotape.
Hey Owen, good to see you. I heard you have a new Pro 9. Tell me more.
Hey Anton, yeah, I wanted to show you my new device. So these new tablets have some special hardware to support Windows Studio effects. So check this out. I'm actually taking a call from my roof right now. The reason you can't hear all this traffic out here is thanks to voice focus. It essentially removes all noise from my mic besides voices. So my voice should be getting through loud and clear. How do I sound?
Perfect.
Great. Yeah, so this background blur that I have on is also new. It's subtle, so you get some of the beauty of my surroundings, but it keeps the focus on me. And I'm sure you noticed it seems like I have a personal cameraman because anywhere I move around my device, the camera keeps me in frame. And that's thanks to auto framing. I feel a lot more comfortable in my video calls, and with all these features, I could probably take a call just about anywhere.
Thank you. That was so great to see you. Bye.
I love this video. It shows how we can essentially offload what was once a cloud-based or CPU feature and process it locally on an NPU. Are there any advantages that I'm missing here, Fred?
Well, the big win here is by moving effects like voice focus, portrait blur, and automatic framing to the NPU, these effects can now run at a higher level of fidelity, concurrently, and use less power. Ultimately, this provides a better experience for the user while preserving battery life. It's a win-win.
Hey, why don't we take a look at this Surface Pro 9 5G and how you actually turn on Windows Studio effects?
Absolutely. Check this out, Frank. So on an NPU-capable device, you'll see that in the Surface app, there's a new tab called Windows Studio Effects.
There it is.
And so if I expand this, what this does is it allows me to go adjust either my camera effects or my audio effects. So watch what happens when I click Set up Camera Effects.
Oh wow, it brings up Windows settings.
It deep links directly to the camera settings in the settings dialog with the OS. And so what you can see here now, again, NPU capable machine with Windows Studio, I have automatic framing as a switch, I've got eye contacts, and I have two different background effects I can pick, standard blur or portrait blur.
You know what I love about that is that seems like now it's actually applicable to the actual camera, where before you would all see those things in apps. But now this is actually a global setting for the camera on the device.
That's a super important point that we haven't yet talked about, which was you're correct. So like other apps that use the audio and video channels, whether they're third-party communication apps or even the inbox camera app, will take advantage of these effects that you have toggled on in the settings.
That is awesome. I think that's going to help Teams performance as well.
It will.
So Fred, I know one of your roles is to help drive adoption of NPU features and applications within Windows. From earlier discussions though, it sounds like there's not quite yet there a universal set of libraries to develop on, like maybe what a GPU has with OpenGL. So how does development work for NPUs in the Windows ecosystem, start? And what are some of the building blocks that a developer should know?
Right, that's a good conversation. So we have a few different ways to target an NPU from a Windows perspective. For example, Qualcomm makes available their Snapdragon Neural Processing Engine APIs for developers who want to run directly on the metal, inference their models directly on that NPU. All that said, we're working on a more comprehensive solution for developers that allows for abstracting away the specific hardware architecture and then relies on the tool chain to do the hard work. You can expect to hear much more about this between now and our annual Build Conference next year.
Oh, I look forward to that. I love the Build Conference. So Fred, I want to thank you so much for this terrific information. I know I've learned a lot. And honestly, if I watch this video a few times, I may be able to train my brain on how to make a neural map of the information that you've shared. So thanks so much.
Absolutely. Thanks, Frank. That was a lot of fun.
All right. Now that we've seen some of the amazing capabilities that an NPU can produce, let's talk to somebody from the company that actually built the silicon and makes it all happen. I'm excited to be joined by Craig Tillilian, Director of Field Application Engineering at Qualcomm Technologies. Hey, Craig.
Hi, Frank.
Yeah, no, it's great to see you again. So Craig and I have actually known each other for many years. We share some history in that we both worked for Microsoft together, but during the dot-com era of the 90s, Craig actually worked at Sun Microsystems and I worked at Silicon Graphics. The reason I mention this is that it brings about my first question for Craig. So Craig, back in the day when SGI and Sun made computers, they were essentially, pretty complex. The CPU consisted of a board that had a MIPS processor or a Spark processor on it. We had a board that was dedicated for the GPU or the graphics processing, and we even had another board that was just for all the I/O that took place throughout the device. These devices were huge, and they needed 220 volt power. This architecture just doesn't scale itself to the needs of mobile professionals. Now, I know that Qualcomm has been a leader in the space of system-on-chip architecture, and in particular, ARM-based processors. So Craig, can you review for us the design of the Snapdragon 8cx Gen 3 processor and how the NPUs, or those neural processing units, are used throughout this powerful system-on-chip design?
Yeah, absolutely. And Frank, thanks for the trip down memory lane. I remember back in the day with these Unix devices from Sun and SGI, we called them pizza boxes because they were literally the size of a pizza box and you could barely fit them under your arm. With the SoC architecture now, it's literally the size of a postage stamp. And within that small footprint, you're able to have an engine of dedicated custom processors that do different things. So you obviously have a CPU, but you also have a graphics engine. You have an AI engine, a security engine, and these are all like processing units that are trained to do specific tasks really efficiently and at a very low power. So we're able to achieve incredible performance per watt. It's actually leading the industry. And because we came from the handset space where we obviously have limited real estate to design all this, we were able to transition this into a Windows PC now.
And what I love about it is we're taking this handset space technology, and because of things like hybrid work, which we probably didn't predict, 5 years ago, and the move to hybrid, but now in a PC, we're able to bring that technology, thanks to Qualcomm, into those different spaces. And I know we've talked about all the different effects and capabilities we can bring in AI for good. Now, Craig, I know that Surface isn't the only manufacturer that utilizes the Qualcomm Snapdragon 8cx Gen 3 processor, but we have a special relationship with Qualcomm that's allowed us to enhance the performance and the AI capabilities of the device in what we commonly call the SQ3 processor. Now, can you share with us a little bit more about this relationship between our two companies?
Yeah, the journey that Qualcomm and Microsoft have been on it's almost been a decade long now. If you go back to what was Windows RT, that was an ARM-based operating system, and there was some challenges with that because it didn't allow for support of x86 applications. So we worked closely with Microsoft over the years, and with Windows 10, you introduced the ability to run x86 applications in a 32-bit emulation mode. And now with Windows 11, you have 64-bit emulation support for x86 apps. So in essence, you can run applications both in native ARM or emulate them if they're 32 or 64-bit. And part of that was really a way of working closely with Microsoft to design the capabilities of our SoC architecture along with what the operating system could handle. And recently at Build in March of this year, we announced with Microsoft a concept known as Project Volterra, which introduced the ability to get a developer kit of our 8cx Gen 3 processor, and now ISVs could start to test and certify their applications for the Windows on ARM environment. You also now have support in Azure for Windows on ARM instances, which is something that's important, again, for the developer ecosystem. And then lastly, Qualcomm, we recently introduced a concept known as an SDK for neural processing, known as the Snapdragon Neural Processing Environment, where ISVs can actually train their applications to take full advantage of the various types of neural processing units and so forth that are on our SoC.
No, I love that. I particularly love that a number of things that you kind of mentioned are keyed off for me. One is how long we've been at this with Qualcomm. He talks about 10 years. I mean, that's the anniversary of Surface is here on our 10th anniversary right now. And the fact that we built RT together, I think we still have some RTs to sell out there. They're probably sitting in some warehouses still. I know you and I probably have one on our shelf back in the day. But I hear a lot about this evolution, and it's great to hear like what Fred was referring to before about development kits being developed as well. That makes it easier for developers to essentially develop for this amazing product that absolutely is the future of computation. Speaking of that though, I hear a lot about this term TOPS. What does TOPS mean, and why is it important to an NPU on your Gen 3 HCX processor?
Yeah, so TOPS is an acronym for trillions of operations per second, and really what it means is when you have a SOC architecture, what you're doing is you're creating these dedicated engines that specialize on specific tasks, and the whole goal here is how many tasks can I complete in a short amount of time? So that number is measurable in terms of TOPS. So when we have a dedicated AI engine, the question is how many times can you run through inference models to really determine what the outcome will be? So TOPS is an industry standard that's used by the likes of us and other platforms and OEMs out there.
Yeah, no, that's amazing. And also just your ability to carve off the portion that you want in order to get work done. It's, you have that ability to play around with that, it seems like, on the SOC itself. So, hey, when I was chatting with Fred earlier, we talked about NPU's ability to be trained, essentially that AI portion of trained and inference. And what are essentially the particular capabilities that you do train them for? So I guess that would be my question to you next is, when we're looking at that HCX Gen 3, what are some of the capabilities that the actual processor is trained to do? And specifically in the space of hybrid work, how is it being trained to help out with hybrid work scenarios?
Yeah, today's modern devices, modern PCs have a ton of AI accelerated experiences available to them. And the Surface Pro X, the first generation, the SQ1, actually took advantage of this. There was a concept known as eye gaze, where when you were looking at the camera for, say, a video call, if your eyes veered off to the right or to the left, it would actually immediately course correct that so that the person on the other end didn't even see that your eyes sort of swayed away from the camera. So that was sort of the first introduction of that. Today's SQ3, that platform, some of those experiences include things like auto framing. You have noise cancellation, voice activation, face detection, gesture tracking. A lot of these things are just part of that sort of set of AI experiences that have been trained into the NPU that you will be able to take advantage of with any of these devices.
Yeah, and what I love about that, because it's in an NPU, it's reducing the heat being used. It provides for better battery life, like the new Surface Pro 9 5G provides up to 20 hours of battery life. So all these little capabilities that are brought into NPU where it makes sense is amazing to see. One that's actually kind of always top of mind, especially in the enterprise space, is the idea of security. And I know that on the HCX Gen 3, you've actually built in a special NPU, a dedicated NPU, just for the TPM, which is the security processor that in the past has been a discrete chip that was on the motherboard, but is now actually embedded into the system on chip design. Now we codenamed that Pluton, but maybe you could tell us what are some of the advantages of implementing a TPM within the SOC of the Gen 3 HCX.
Yeah, so before the implementation of Pluton on our SOC, you in essence had an external module that handled that was basically the TPM, and so now you're removing that external module, so you're reducing the attack vector or attack surface, which obviously is important when you think of how do you make a device more secure. The other element is because Pluton is integrated into our SPU, our secure processing unit. We're seeing 7 times faster threat detection and remediation. So you'll see significantly better performance at a security level. And then the other thing is that we're also seeing faster boot times because, again, because everything is so tightly integrated from a security perspective. When you go from cold start all the way up to desktop, you'll have a much faster boot time, a better connected standby experience, and so forth.
No, that's amazing. You know, these levels of security is truly amazing. It helps harden the device even further. And so this device, like the Surface Pro 9 5G, you know, being a secured core PC, really stands for something in the enterprise and something that people can count on. So I'd be remiss not to point out all of the other places in the hybrid work environment where Qualcomm and their implementation of AI and NPU technology is showing up. So Craig, can you talk a little bit more about this?
Yeah, absolutely, Frank. You know, so we've seen our SOC being adopted not just across the mobile handset space and the PC, but in these new meeting room spaces that enterprises are investing in as people return back to work. So when you look at companies like Poly and Logitech and Bose, what they're doing is they're actually putting our SOC into their cameras, into their speaker systems, and they're able to actually do auto framing, noise cancellation, voice recognition, and so forth. No different than you see on these mobile PCs. You're now seeing those benefits transcend into the new meeting room spaces.
Yeah, no, that's amazing. I mean, when I look at a device like this Surface Duo 2 that has a Qualcomm Snapdragon 888 inside of it, or the new Surface Pro 9 with the 8CX Gen 3, and then being able to pull that into all the different technologies that we have in meeting room spaces as well, you're starting to see where NPUs and AI for good are really starting to show up. So Craig, thanks so much. It's been an absolute pleasure to see you again and talk about AI. Who knew that we would ever be doing such a thing? So I just want to say thank you.
Yeah, no, thank you, Frank. It was great to reconnect.
All right. Thanks a lot, everyone. As Craig pointed out, we're seeing the implementation of AI technology in so many areas that simply improve the experience of hybrid work. This past year, we announced a 4K AI camera for the Surface Hub that supplies auto framing and autofocus for all people that are in the room. We've also built AI into the Surface Laptop Studio that provides voice clarity to reduce outside noises and allows each voice in the call to be clearly heard. We've built our very own Surface AI face detection algorithm. It perfects exposure in your video calls, enhancing your face even in the toughest lighting conditions so that you always look great on camera. That's pretty important. In fact, our AI dev team used the GPU power of the Surface Laptop Studio to build out the prototype for a neural network, and the results are stunning. Thanks to the purpose-built hardware such as NPUs and operating systems such as Windows 11 that take advantage of these NPUs, we'll continue to see significant advancements made in this space. It's already super cool, just like this cat. Thanks for joining us today, and we'll see you again really soon. To learn more about these topics discussed in the session and the amazing Surface products shown, head off to the locations listed below. See ya!